Well, welcome everybody. This is our last time that we're meeting without a final going on, I guess. And I hope that it's been an informational, informative, hopefully interesting as well class focused on mechanics and materials. I thought maybe what we could do, this is kind of like session 25 plus, all right, is of course answer questions, but just kind of go through topics and cover things. The final, because it's shortened for this summer class, is going to focus mostly on the latest material, so it won't be as cumulative as some of the other exams that you've seen. Yes, Matt.
Is it 40 points?
We won't get to 40 points. Not with the hour and 55 minutes that we have versus the normal 180 minutes.
Everything after the second exam went up to session 20, right?
Yes. So what's new? Well, let's look at it. All right. So if we look at where we've gone, right? The last exam went through session 20, okay? And then we covered plane strain the day before the exam number 2, but that was not on exam number 2. And we have 2 sessions on failure criteria, then 2 sessions again on beams. We've covered beams quite a bit, okay? And if we kind of, take the big perspective in terms of what have we learned this semester, essentially we've learned how to take the situations that you studied in statics, where you have some type of structure, usually a simple structure, a bar, a rod being twisted, a beam, or our new knowledge about pressure vessels. So we actually cover a thin-walled vessel or structure for the first time. So we've taken those situations where you have some loading that you're familiar with, right? An applied moment, applied distributed force, applied force, and we've been able to go and say, look, here are the stresses associated with those forces, with those moments, with those distributed forces, or the moment applied at a particular location. And from that, once we know what the stresses are in the structure, we can then make some estimates for whether or not that structure will fail. Okay. And how do we know that? Because we have this big structure with distributions of stresses, but we go back to the simple testing that we did on a material, or someone else did a material that they put on a spec sheet. And with that, we can tell whether or not the stresses we have are going to exceed the stresses that they found when they tested the material by itself. Okay. Now, there are some tricks there, right? Because your tensile test that might have been done, or your torsion test that might have been done on a material, okay, could have a state of stress that's been transformed, right? That's why we did the angles of rotation to what we have in a structure. Or our structures could have combined loadings, right? Where you have not just a normal stress, or not just a shear stress, not just pure shear, right? But you have some combination of shear stress and normal stresses. And so then we had to figure out what an equivalent stress would be to go back to the material testing, right? So the approaches in this class are very powerful. Essentially, we can figure out what the stresses are in primitive, well, let's not say primitive, that makes it sound like they're not useful, in a set of commonly used structures, right? And these include bars, right? And that's normal loading. They include rods. That's typically torsional loading. They include beams, right, which has transverse loading typically. They include the thin-walled pressure vessels. Which has gauge pressure. Okay. Inside. And we can also map, we can figure out, we can use data or specs from material producers and testers, okay, to relate structures or structural stresses to material properties. Okay, and we said this kind of in the beginning of the class. You're not going to take, it's not practical and not a very efficient use of our time to take an enormous structure and put it in a tensile testing machine, right? And then figure out, oh, is it going to fail or not? No, what we want to be able to do is take a little bit of chunky material, right? Figure out what its material properties are, and then design the big structure and predict whether or not we're going to have stresses that exceed what we found in our testing of the little chunk of material. Okay. So that's one thing we've kind of done. Another thing we've done is we've looked at strains, right? So we've looked at strains to get an idea of how structures might deform. Okay, and it was pretty straightforward, right, in the beginning where we said, hey, delta is equal to PL over EA for a bar. Okay, it's we figured out the angle of twist, right? The TL over JG, right? For the theta in radians. We didn't really think too much about how much, well, we did do some, we're not looking, we don't care too much about like the overall deformation of the pressure vessel. We hope it's very small, but we did look at the strain, the hoop strain, right? And we did look at how having layered shells of a pressure vessel might affect the stresses that are in those individual quantities, okay, or individual shells. So, and then the kind of the climax here is looking at deformations in beams. Okay, so now those deformations are the most visible, okay, of the ones we've discussed. I mean, yes, if you have a rubber band and you stretch it, you can normally, right, you can see it. But for the types of the materials that we've been dealing with, the lower carbon steels, which are ductile, the aluminums. Okay, these materials that have, pretty high elastic moduli. Deformation is most obvious in these beams, okay, that extend, right? And so it's important for certain applications to know that, okay, that deformation is not going to be too large. And if I build my building with all these beams, right, it's not going to sag too much in the middle of a floor or something of that nature. Okay, so this is kind of the big perspective. Okay, we have a bunch of tools in there. All right, we have the tools of the stress transformations. We have tools associated with kind of calculations relating the strains to these deformations and the beams that we're seeing. We have a number of expressions that we've derived to be able to figure out things like PL over EA. And we've also covered a decent amount of material testing. So that's a pretty big overview on the large downward perspective on what we're able to do and what we've kind of learned. And the applications range from civil to mechanical to biomedical to aerospace fields to others as well that I'm not naming. When we walk around and we look at things that are just sitting there, we kind of have this X-ray vision now. We can kind of begin to visualize, oh, that's where it might fail. Okay, that's where the stress is going to be the highest. If I sit on it right here, right? Just even simple things, right? When you choose where to sit on a bench, all right? You know that if the bench has just, kind of two legs or two supports on either side, if I sit in the middle, I'm going to have the most deflection, right? If I sit closer to one of the supports, I'm going to have less deflection. I'm going to put less strain, less stress on the structure. Okay? So I hope it's a little bit eye-opening. We did some fun problems with pressure vessels and the ups and downs of airplanes, and I think we may not think about the fact that the internal pressure is a significant factor in the design of the fuselages, okay, for airplanes, but it is. Okay, so any questions? Any questions now? Let's open it up to questions. What would you like to review? Oh, and I should say a couple other things. Sorry, while you're thinking. So one, I still need to fix this exam, 2015 exam 1, question 1. I just don't even bother doing it. 1, it's super tedious, okay, and 2, the answer in the solutions is not correct, okay? So I'm not saying you don't look at the other problems, but like I've said in the past, I would start backwards. Oh, sorry, it's not that one, it's this one, the final exam. I would start backwards, okay? I would start, first with 2023, then 2022, then 2020, when you're going about studying for this. So if you get to the first problem on 2015, that one was pretty rough. I would just skip that one, okay? Carlos had a very nice comment in the GroupMe, and there was a typo for, whoops, this is number 25, I need 24. There was a typo that I made in in this problem, okay? So I had written PL over 2 times x1 and PL over 2 times x2. That doesn't make sense. This is a moment, right? That moments should have force times length or length times force, and so I had accidentally put in an extra PL or extra L. So the updated slides for this summer session should now have the correct results. Okay, and any other things that I've messed up. We'll have the exam here tomorrow. You have 3 sheets of anything you want written on them. Okay, and that's about that. And bring a calculator again, of course. Okay, so now really questions that you might want to cover.
Could you go over a question that if you weren't our teacher, you'd expect to be on our exam tomorrow?
Okay, so if I weren't your teacher, and what would I guess? Okay,
Yeah.
so this is going to be a longer list than I think would be on the exam.
Okay.
All right, if that's fair.
That's
Okay.
fine,
All right.
yeah.
So this is a longer list. All right. So I would be able to measure strain on a structure and relate that to stress. Okay, this is the plane strains. So measure. So you have strain gauges. Okay, or rosettes. And I would not use a 60-60 degree one. I would use a 45-45 one because it's significantly simpler. Okay, so 45-45 rosette, and be able to go from strain measurement, right, of the different gauges, right? The gauges in that case are the individual strain sensors, okay, that can only measure in one direction, but then you have them oriented relative to each other, so then you could come up with the 2.5D state of stress, okay, to stress, right? If I were studying for this exam, I would definitely know the failure criteria, and I would say max normal, max shear, right? So max normal is brittle, max shear, and von Mises. Okay, the equivalent. Those are kind of the big 3. The modified more, probably not something I would worry about. Okay. The next topic is beams, right? So the beams, I think it's pretty important to know how to do the integration, okay, right? So we need to know that EI right? We need to know that equation. We need to know the derivatives of that. But more importantly, we probably need to know that, dm dx equals v is still truth. Okay, dv dx equals w. Those are still truth, right? This combination is very important. Okay, so that the dm dx equals v, right, and the dv dx is equal to w. Okay, and it might be a good idea to look at maybe past exams from this summer to get an idea of the type of structure that you might want to be able to handle for measuring deflection. Okay, because we haven't talk about this, the deflection, all right? Okay.
So if we were to go over deflection, would it be like, let's say, like, I don't know, question 1 from this past exam, like, but like another part that would say deflection? This
You
is like too
know,
specific,
it's
like-
just, I don't think that's a bad idea.
Okay.
I don't think that's a bad idea. To
So
know.
it won't be its own question, it'd be building on like previous stuff.
You know, we'll see. All right.
That's fine. No,
But if you weren't sure how to calculate out the moment, right, across that first problem with that distributed force, you know, and it was a triangular distributed force, I think it would be a good idea to know how to do that.
Oh, yeah.
Okay, just, you know, it's just me.
No, I know how to do that.
All right. Now, the thing that we have not covered so much, but that session 25 really hammers on, is what to do with indeterminate beams. Okay. And what is an indeterminate beam? Well, that beam, so session 25, right, is all about. Well, it's not all about. It has a few different things, right? But parts 1 and part 2 heavily rely on superposition. Okay, so you can use superposition. So, for example, if you look at the last semester, right, final exam, which again I think is, if you're going to pick any of the final exams to review, first do the last semester's one. You'll see that, sometimes you're given these charts, all right? And we have to be, and as I talk about in the videos, they use different sign conventions, so be very, very, very careful, okay? Very careful.
When you say sign convention, you mean just like the positive for a deflection? Wow, no, just that.
Yes, that's the sign. So we consider V as positive if it's deflecting upward. Gravity works downward, so I can completely see why people would be like, doesn't it just make more sense to write V positive going downward? That's not what Hibbler's done, all right? And we've developed a whole set of conventions, and I don't want to mess up one, right? If I just change one, then I have to start flipping arrows on other conventions, right? But yes, V, this is a convention, right? Conventions. It's like, right? But just, V of X is greater than 0 when deflection is upward. Okay?
They times negative, so I think it was times. You don't know time for that.
Yeah.
How's that?
These statically indeterminate systems are quite painful. All right.
What is, sorry.
Huh?
Can you repeat that one more time?
Just statically indeterminate systems can be quite painful. Okay, to solve. But I do like. Okay, I like situations where I'm not using the method of integration. So the method of integration, right, is a possibility, but it's a lot of math usually. Okay, so if you have a statically indeterminate system and you can break it down, okay, and use the tables instead, you can do the same problems with a lot less math. Okay, so if you say it's a statically indeterminate system and you're going to use the method of integration, which is a fine method, okay, but I've given you the tables, don't do it. Don't use the method of integration, okay? All right, I say try to use the tables, okay? Please try to use the tables, okay? Because it will save your time. Now, there is some pain that can happen when you have a situation where there's some rotation, okay? that we have to account for. So like if you look at, well, there are different examples, but let's just pull up this one. I'm pretty sure I did it on this exam.
Wait, on this exam, are we given those tables?
So you'll be given something like this. This is a table, right? And, you know, and you might also be told that, look, there's a different set of conventions here. Okay, so it's important to know what is up, what is down, okay, and what you can ignore. But even here, all right. Let's see, running experiment. Yeah, that was using, okay. Yeah, so this one we had to use, right. So this one we had to use the fact that there's an angle here, okay. So what's happening, right? This is saying, all right, look, the distributed load, I understand what happens. I understand that I have a nice expression for the distributed load across the entire beam. Okay. But that's not what I was given. I was giving it as half. The distributed load is just along half of the beam. Okay. So if it's along just half the beam, what I have to do is I have to break it down. Okay, so I have across the whole, and then I apply the same amount essentially going upward to counteract this portion here, so that I can get this geometry. So looking at a few of these where you do superposition, okay, to be able to knock out, this is not, I'm sorry, this is actually not a statically indeterminate problem, okay? This one is statically determinate. But being able to know how to rearrange the loads so that you can get an equivalent system is pretty important. And being able to know that there's an angle associated with this is also pretty important. And then you see how this region over here has no internal moments, no internal shear force from here to here, right? That's what we call being along for the ride. So that means that this region essentially is just perfectly, you can think of it as perfectly rigid. Okay, so the deflection that you have, all right, from here to here, this last L over 2, right, that is essentially to say, hey, you know, use a small angle approximation. So it doesn't matter if you take the hypotenuse or you take this one, but essentially you have to say, okay, what's that angle? And I multiply by that length in order to figure out how much it's shot up. Okay, does that make sense? Okay, I'm not sure if I'm making sense, right? Imagine that this is tangent theta, okay, and you've got the opposite and you've got the adjacent. If I know what this length is, I can figure out what the opposite is, right? So that's what we're saying. If it's just a rigid member, rigid region, you know, that's what's being put up. Yeah, this is the indeterminate one. Nope, this one's not indeterminate either. This one is, sorry. See, I can't even. How do I know instantly it's not indeterminate? Because if I remove either of these either of these supports, it just whoop, and it just falls down. Right? I have to be able to remove a constraint and still not have the structure collapse. Okay. So on this exam, it looks like I may not have done a statically indeterminate one. So maybe I shouldn't do a statically indeterminate one. Ah, nope, I did. This one is statically indeterminate. Okay. Yeah, this one is statically indeterminate. Yeah, you see that? Because I could remove this support on the right and this wall would still be okay. Or I could make this a pin, right? So I could remove the constraint on moment over here, and that would also make it statically determinate.
Determinate?
Determinate.
Yeah, okay.
Yeah, if I remove one, I make it statically determinate.
Yeah.
it is statically, currently in this form, it's statically
Yes.
indeterminate. Okay. Okay. And someone noted that I had made a typo. They actually, like this was an expression that I had used, but I was missing a 2 here. So, so anyway, but you could have acceptable because there was a typo. All right. So that's kind of what I would know how to do, right? I would know how to do integration, figure out beams. I'd know how to use the conventions, and I'd be able to handle the superposition. Okay. For determinant and indeterminate beams. Okay. Great. Okay, so I'll just go around. I'll answer questions that people might have. I don't know if anyone. Is anyone here that didn't? Oh, okay, here. Yeah, maybe I can talk to people.
Imagine if you could see like all the people that are coming from science.
I mean, I've had it before, like in mechanic college, Chem 1, we saw like 70 people in the final, like 20 people showed up.
Yeah.
Like less than 1, it was like.
Yeah,
More
more
size
Calc
class.
1 class, no professor.
I don't think
Oh
that
my
will
gosh, class
happen.
is like a 70-person lecture hall, and like about like 50 in the class was there fine.
That's pretty rough.
There's something similar happened in my physics course. They were trying to move programs that semester.
Yeah.
Let's just say it did not work out, even with 20-point curves on every exam. So we ended up with about a quarter of the people starting.
And we're 20. Yeah, from the first 3 when we kind of started like that, and just trying to find a
Yeah, we can deal with that. Might toss it back.
I'm trying to figure out what's wrong with 3 here, but it's just not.
Are the units right?
Yeah, no, I gave up. I restarted.
Because I was like, yeah, I was trying to 3 of them, what is it, what's going on there? Like,
No, I'm just ripping shit off the internet.
I was even trying like maybe it's like 10 to the -6, -3, I tried 0, or negative, positive. Because they didn't say what units it was. It was like, they can be micro, or be meters, no, positive, no, negative. It was, that was weird. And 24, I don't know if it's 24 right or wrong.
24 worked.
24, okay.
Which question?
I think it was 1 or 2, I think it was texting number, I think. It was 24.
What is micrometers 6th?
Yeah. So you can sure which one is the FEA. I was trying to see which way you could convert it to that.
Your trackpad is annoying as hell.
Hmm?
Your trackpad is annoying as hell.
Oh, yeah. It does that.
I can't believe we got one more day in the final.
Yes.
I was talking with Matt about some right here, and you know how he's like, no one's really in too much like danger of failing, assuming they go in the same. They keep saying whatever.
Yeah.
They keep on doing what they do. Everyone does what they've been doing. I was talking to him, and I was like, dude, I sort of cannot. He's including D's in that statement. I swear to fucking God. You know what I mean? Like technically D's fail.
Thing is that, yeah, well,
But if he's including that with that statement, including these, and he's gonna be handing out these as well,
yeah.
I swear to God, dude. Means I have to retake this course, that means we'd have to retake the course.
Yeah, can't get 3 Do you need the classes?
What for?
I don't even know what I'm doing.
The what, 24, 25?
24 Q2.
I think I have it in there actually. Maybe.
I could use this as well.
The thing was working on it, I'm trying.
I see Q1 and Q2.
Yeah. Do I actually, yeah, I don't know if I did my Q2 yet. So I was checking. I don't know if I did.
Do you have Q5 and Q2?
Q5.
If you scroll down.
Q5, 22.
Shit, everybody was.
Yeah, my 22 is done. 22 Q2 is done. And I don't have 24.
Session 24 Q1.
No, I don't have your.
We got session 25 Q3 out of that.
Q3 is what we're on, yeah.
23 Q5.
I don't have that either.
Oh gosh, those are the ones I don't have.
Yeah.
Dude, at least when it's
25 is a little too
Is there an outlet near here?
Yes,
usually was,
right,
yeah.
right in front of.
Yeah, right here.
Whenever I see those, whenever I see the stuff for like the CAD programs, like from the picture, and you can check out that I can't bring myself to do it, because I know it's gonna take 40 hours.
Well, the cat thing was that actually purely close to you, right? Matt, you're close actually. I was looking at it like after I submitted it.
There was no
Versus free
pre-program
CAD.
access.
No, it's only free CAD, right?
Yeah, not the free pro, because the free CAD you could do the analysis on it, which is
Yeah, yeah.
and I got
Oh, wait,
close
so
to
how, like, what do we have to do for the?
You just gotta put the beam in.
It's not that bad to do some free CAD. It really isn't. It's like you can make the beam with like CAD. It's easy to CAD, just make it. It's a small beam and then
I hate when it's.
I have no idea. I have no idea. I know how to use. I'm so good at SolidWorks. Which
you guys have a tutorial on the lecture slides for course 3 or whatever of that lecture. You guys have a tutorial how to make the whole thing.
I only have 3 days to
Wait,
do
for
this,
like-
so I don't know.
The free CAD one.
For 24? Or like the one we first did?
No, the 24, but also the one we first did, there's a tutorial built on how to do free CAD.
Yeah, there is.
Yeah,
But I'm not-
trying to learn how to do
and the
that when I have to study.
I don't need a
this.
final. Yeah. It's not-
Yeah.
Dude, that's why I hate the, I actually use the, what's it called?
The software and shit.
The programming thing where you could just get like calculate.
Oh, Colab, yeah, because
I never use Colab, so I'm sitting there and it's like, why am I, like, why
It's
would
not
I
practice. I don't.
learn how to use this? Like,
a lot
it's-
of equations are there, so it's like you can't like, see how you're supposed to put it in the program. I mean, yeah, I remember math back a while back, but that, I mean, we learned that and then the new material.
Anybody got like a silver Sharpie?
No.
No,
Why
that's
silver?
Because my cover is black, I'm trying to write on it.
I got a pencil.
Oh, could I
Just
use,
write on the paper.
Could I use his, this one?
Hold on. Run up, no.
Trees over some.
But you're 45, sir.
Yeah, it's.
Do I type, I just type in that?
Yeah, you just type those in the. I'm just saying, I space, I guess I could write those. I'm kind of glad I have space now.
Yeah, yeah. The thing is, okay. What am I putting on these next 2 sheets?
I guess mainly the new
Examples.
stuff, like, you know, shape
Just-
factors, examples too.
Yeah, I'm just gonna do an entire.
What's that probably gonna be? I might do that's what, do something like that.
Yeah, that's true.
Like, that's already, if that's gonna be on.
Yeah. Also, yes, there. I think it's. I would appreciate people also knowing that structures can behave as springs, right? So that's another thing. And sometimes that can make things easier. Actually. Okay.
I mean, I can kind of see that, because that work when I'm like stacking pallets, I'll put it on and I see it's kind of spring up and up.
Yeah, right. If nothing else, maybe you've got an idea as you stack more and more pallets, right? the deflection, like it becomes more squishy.
Yeah.
Well, it starts leaning. Yeah, that's another problem, right? As we make, so it's kind of interesting, right? It's in at least in a normal compression type way, right? When you make it thicker, right? It's like, oh, that's kind of fun, right? It becomes more squishy.
Yeah.
The spring constant goes down. As you make a beam thicker, though, right? As you make it larger in its height or its thickness, and you go across, that of course will make it stiffer, because we think about, okay, what's happening at the end usually. Okay, Carlos.
You don't remember the straight. Wait, honestly,
I kind of like this.
Honestly, and like Desmos is actually like, I was like, oh, wait, we're gonna do yesterday, and Desmos is actually like,
Desmos is nice.
it really is nice.
Yeah, because it's a graphic calculator,
It is, it's like.
but it, yeah.
But it's
Like you don't have to worry about doing,
like,
like, you
yeah.
don't have to worry about fucking with the
Yes,
calculation.
that's or the
Each
retyping.
time,
That's
I've had this thing since sophomore year of high school, and it was,
I've had
If I didn't
since
have it-
years.
I fucking hate those things.
Dude, they're so good.
They should be shot, whoever made them.
why?
What?
They're
I charge
$160
$160 for something.
No, I
worse
got
than anything else on the computer. I mean, I can,
But dude,
Yeah.
it's not a computer, like the fact that,
and also.
you see how big this thing is?
When's the last time you didn't have a computer on you?
When I was
During
taking my
exam?
exam.
Exactly.
That's an exam, yeah.
Exactly, what do you mean
Exam.
exactly? You can't say exactly when the exam is the only thing we're getting tested on this fucking class.
I fully attribute part of the reason as to why I'm good at math is because I refused to get a fancy calculator, so I had to actually learn how to do everything.
Mine could
Wait,
be basic
what?
integrals.
I have
but
to
it's kinda-
learn how to do it.
I
Wait,
learned-
literally,
I
what do you
learned-
mean?
Yeah, kind of.
Dude, Desmos is like the best calculator. And I'm not saying
Yeah,
that, I'm not.
for doing problems, but like the integrals and shit, I never had a calculator.
Yeah,
physics,
You
I
can't
didn't-
do it with the calculator.
I
You can't
didn't
do it
bring
with
a
the
You
calculator.
can,
Yeah.
this one you can do a basic one.
This is
Well,
literally,
that-
all
I-
this is
Well, I don't
getting,
really
all that is
I
getting
can do basic.
I
the
know.
closest possible to
Yeah,
Desmos on
But I can't- I don't
the
need
exam.
I charged $30,000 for it a year.
For
So you're
what?
saying if you're gonna
They're
get
just
one,
expensive.
so you're saying if you're gonna get, Desmos is gonna give you theirs for free, you wouldn't want, you wouldn't.
But I would take it, I still probably wouldn't use it much.
I feel you sound like someone who lost their calculator junior
That's
year.
exactly what
Yeah, I can't believe I just called that.
The year and everything too.
Yeah.
Now you lost your calculator and now you were salty about that, so you never.
That's actually honestly, I'm really proud of myself.
Yeah, you know, that's how, yeah. You got this village one?
It's because I've known this kid for so long.
You guys are origin story.
Well, that's
That's
something funny.
so-
So, I lost my calculator a few years as well,
Yeah.
but, that was when like our the one teacher, she had like chemistry, she had extra graphic calculators we could use,
The yellow ones.
and
No,
no,
didn't.
it was like regular.
Oh yeah, I had it for a while, it's a property of Clever High School.
Yeah, I know.
And so, what's it called? It was like a TA-84.
Yeah.
And then like the day I was supposed to give it back to her, she was out because she had cancer.
Oh.
And I didn't know this stole the calculator. And I still have it in my room. In my defense, someone broke into my gym locker in the extension. So like,
So, yeah.
it wasn't like I just left it out,
Yeah.
I think.
Probably.
I don't know how the urge to do this.
What?
Wait, what are you guys doing tonight?
Studying.
You guys are on work right now, right?
I have work on
Another
it.
class after this.
I have class right after this, but like after, whenever I get home, I'm down. Like, we should just literally like 6 hours call.
Yeah.
Yeah.
Alright, boys, we got any idea what's going on here?
Just
for
work
session
through
20?
problems.
For
But
1, 2, I was trying to solve that. 2, I was questioning about. 1, I was doing integrals on, and like that's the one I think I was working on the most, but I couldn't.
I say we work along with questions that we know we get in the exam, and then from
Yeah.
that,
And then you
random
figure out how to
equations
do
and stuff,
it,
and literally just like, I'm not even kidding, like last night I was doing a problem and like, I was considering just making that with my, just
Just
ripping
that
it out and
equation,
making
yeah.
an equation sheet.
I mean, that could be, yeah.
Yeah. I don't know if it was a good question, but like, I don't know. Just work
But like,
through-
that's what I think, giving us those graphs as practice. It just starts with like, I was asking, is
What's
I just don't understand. Okay, so here's
Huey is on the force, he's a two part.
I have been super fucking lazy ever since ever since the last exam. I've been
Yeah.
extremely
It's
fucking
only been a
lazy.
fucking week.
It really
Yeah.
only happened a week.
It's like this week, it's a kind of a thing of like, it's only 5 units, right? Instead of 10.
But you gotta remember, those are all compounding everything you learn.
I know. I
Yeah,
don't want to
remember
think
that.
about it, okay?
Yeah.
I don't want to think
Yeah.
about it.
See, I have one there where if you put it into, if you look up any of the other problems like on here,
Mhm.
like if you put in any other numbers, it gives me the right answer, but it won't give me the right answer for not a check. Yeah,
You have a check?
I broke
Dude,
down.
I was talking to my extended family, and they're asking about this page, and I was like, this sucks, but there's like 2 things that really get me and
Caffeine
they're
and
like
alcohol.
that, and they're like, oh, you guess one from check, and I'm like, alright, so there are 3 things.
Yeah.
And my dad came from behind me sometimes, let's check.
Well,
Why
okay.
can't prove it?
And I explained it to him, and he's like, so you cheated on your homework, so that's why you struggle with certain classes, and I'm sitting there just like,
It's like, no, but you see.
Well,
My
yeah, but
sister-
if I did have it, I would look
I
at this
explained,
question.
I actually don't
and
actually
check
worry
I
about it.
explained,
I
and I
actually
was
haven't
like, the
checked
problem
it.
with it, I tried to explain to him, I
But
was
I
like,
could
listen,
Google
you
it.
don't know the answer to a problem, and you've been sitting there working on it. There
It's
is
not gonna
no
change.
magical,
Yeah,
like,
well, you know what?
there is thing you're gonna find that's gonna solve the issue for you. You're not gonna know until someone shows you this is what you should have done. So if you sit there for an hour and a half, the problem,
Staring.
like if,
Yeah.
you know what I mean, you're not gonna
Yeah.
know it. Whereas if you see someone solve it, you're like,
You know what they-
that.
You know what I've said to my parents once, that they were like, oh shit. Because they were arguing like, oh, school must be so much easier with computers. I'm like, no, it fucking ruined it. And they're like, what do you mean? And I'm like, everything's due at midnight. If you have 6 hours worth of homework and you start your homework at 8 o'clock at night, you can't just pull it all night or get it all done. You're just fucked.
Yeah.
Like you gotta know, like it's due at midnight. That's crazy.
On top of that, they
Yeah.
start when
They're gonna
they
tell you,
and
and start at 8 o'clock, but you're sorry. Yeah.
Well, how the fuck can I not start at 8 o'clock if my classes run from 8 in the morning to 8 o'clock at night?
Yeah.
I know my only option is to start at 8 o'clock. And I got 6 hours worth of homework due tomorrow, aside today. The fuck? How am I supposed to operate here?
What were you saying?
I was saying on top of that, any class, any math class that starts incorporating computers into their problems, that is such a higher level and like that makes it such a higher degree of difficulty to do than anything that.
Because
is
doing math
on a
on a
piece of
computer
paper.
is coding.
It really is.
Exactly.
Yeah.
Yeah,
Guys, we got anything for section
And
20.
then that's a whole different thing.
24?
yeah, that's 24, we're struggling.
Wait, 24 is, I think 24, I did the main part, which is what I showed you guys for that, the equation and then the cat. That's
For
it.
Q1? Or,
I love
Q3.
going to family gatherings and being an engineer because they're like,
Oh, yeah, I like
I'm
it.
like crazy. I'm
Yeah, I
like
like it.
crazy.
I like it. Work
Yeah.
like, oh, you're a fucking genius. I'm like, yeah,
Yeah.
but it's like a dumbass. Like, cool. That's
well, I got 3 engineers in my family, so.
Yeah, that's.
I had no engineers. I have a contractor and I have a nurse in my family.
Dude, it's so funny during all this stuff, because when I'll talk about the classes and stuff like that, and like troubles with like certain classes,
Yeah.
my dad was a history major.
Yeah, bro.
So like he doesn't, he is like the person who's like, oh, you didn't do good enough, you should have just reread the chapter.
Okay,
Right?
my
It's like,
parents,
I'm sitting there, I'm like,
they know how, okay, not that my parents are stupid, but they know how, like, they could never even attempt the math that I'm doing. So my parents really just like stand back and like let me do whatever the fuck I want and don't give me shit. Because like they're just
Mine's
I'm like, hey, it's
like
working so far.
they're just like,
Like it's working.
you're
so
getting
far.
done, like just keep doing it, bro.
Bro, most of my cousins who always had like better grades than me and shit in college, but that's because they would get all A's, and then they would, literally one of them took Calc 3 times, or Calc 1 3 times. Calc 1. And I'm like, yeah, I don't give a shit if your GPA is a 3.8 if your hardest class is fucking.
Thing is,
Like,
if we did that, we'd be here for 6 years.
Yeah.
If I took Calculus 3 times, I'd be here for 6 years.
Yeah,
Like,
you know that.
yeah.
exactly. Yeah.
Dude,
You know what's the worst? When someone says, why don't you just take these classes to boost your GPA? When? Fucking when? I'm barely
Yes.
keeping up as is.
I know.
When
Like,
you
how
think
am I
I'm
gonna
fit
fit
in
in
a
this
six
fucking
fucking
class?
class?
Even
Yeah.
the electives role, like, oh, use Calc 2 for your electives. Like, yeah, I'll take aerospace propulsion, something like that.
the fact that one of our, like, I don't know if it's the same here, one of our electives is forced to be either chemistry 2, physics 2,
Not physics 2, physics is required.
Yeah, thanks.
not for me.
Really?
Well, you know,
How?
Well,
which
what
has
are you
in town school you're coming to.
Wait, you don't have to take physics to be an engineer?
Physics
Can we just take
to be
physics?
mechanical engineering.
I
you
just
don't
took
take
physics 1. I just took physics 1.
Dude, I would go check that because I think you're wrong there. There's no way that you're a mechanical
Whereas if
engineering.
you get to the end of the 4 years, it'd be like 2. If you get to the end of the 4 years.
My
it'd be
calc
like
college
2.
for at least 2 physics, just for associate's engineering.
And dude, I've checked it like 8 times.
Dude,
I've talked to my advisor about it.
Mr. Mazzio, does it sound right that there's a mechanical engineering program out there that doesn't require you to take physics 2? I've never
For
heard
a
of
bachelor's, I'm gonna say bachelor's too.
I have no comment. I mean, how many
Well, physics 2,
Some
I learned, I've been
have-
but it's all like, it's like lenses and shit. I'm sorry, but like I'm sorry, me knowing how like
Yeah.
lenses and reflections work, that's not gonna help me.
That's not gonna be physics 4, right?
Wait.
No, physics 2 is a lot of things with circuits and also.
Well, 2A.
Yeah.
2A.
So, knowing about the charge in a sphere and that kind of stuff.
I hate that. That is the
You know,
worst physics ever.
it's like,
Yeah, I forget what's
And you could ask yourselves, how relevant is that to mechanical engineering? But circuits and mechatronics, right? We have now our mechatronics class, which used to be principles of electrical engineering. Like, that we used to kind of do that.
I'm in mechatronics right now.
Yeah, so that material, because of our connection to robotics and systems that need to have actuators, right, and motors and stuff, it's really important to know that, I feel, from a practical perspective. So I won't comment too much on the physics 2 issue.
So wait,
Well, maybe it's not relevant. I've just never heard of a school that didn't
Wait.
require it.
Why does mechanical engineering has 2A and 2B, but aerospace has only 2A?
So, exactly, that's one I was...
But just on principle.
Yes.
Weird. Like I want to learn about relativity.
It's like,
There's no point in taking. a
Yeah, I
class
can do my own.
That usually goes over.
Yes.
subtraction, or
Isn't that important, like, to
if
be,
I'm
like, what
taking
they do
4
to be?
classes the next 4 years, one going over addition, one going over.
I'm not... yeah, it's...
So I think they break it up more like that.
Our
There's no
aerospace
point
program
in
has a
taking
lot
a
of
class if
requirements
we're gonna go into more depth.
and other courses, right? And so something's gotta give.
Yeah.
And that's one of the ones that we decided. So we'll see what happens in the
Can you
future.
go over question 3 for the last session?
like all these.
24 or
I've done it
20?
like 15 times.
Wait, which
25.
25, 3.
You get
Okay.
what I'm saying? It's like, it's important, but like, they're not really related
I'm
to each
just
other as much as they are to like their individual.
I'm gonna still have
Oh.
it though, because my physics program
Okay.
absolutely sucked.
All right. So there's a question here, right, about... I just happen to have this one open, Michael. It just like magically appeared. Okay, so the first thing here is that this is an indeterminate system, right? So I could remove the moment constraint or the deflection constraint, right? The force constraint or the moment constraint on this right side or on this left side, right? And it would be determinate, but it's statically indeterminate, right? And so the question is, okay, how do we go about approaching this? And here are some different things that we can use, right? So this would be, kind of the statically determinate one. And what we're saying is that this constraint here, that wall constraint, is applying some type of moment, right, and some type of force, okay? Probably not downward, okay? Probably upward, right? And, and this is probably applying moment in the opposite direction, if I'm doing it on the right, okay? So how do we look at this? Well, we can look at it as, okay, there's some force being applied, right? And we know, in fact, that, okay, it's it's P over 2 that's being applied. It's split evenly between those two. It's a symmetric problem. And we have some moment being applied on the right, okay? But I don't know exactly what that is yet, okay? But we add the deflections up, all right? Now, this is one of those things where we need to be a little bit careful, and we can use our convention, right? So I can say delta 1, delta 2, delta 3, and add them all equal to each other, right? And delta 2 and delta 3, we're going to say those are positive because those are upward. But delta 1, we want to be careful, and we'll say it's negative. Okay? So this is taking what I know. I'm not quite sure what MO is here, all right? But these other three, okay, are fine, okay? They're fine. Okay. And so I get this expression out, okay? And what I did here is I, multiplying both sides by this expression to kind of make it easier, right? Because we had L squares in all of them, and we had the 48 EI down there, right? So now we can figure out what MO is. So now after we've used superposition to figure out what the M naught or the MO is. Okay, that's nice. But now we have to figure out, okay, what's happening with the deflection, okay, across the beam. And this is, not super trivial. Okay. Hey, good morning. So what do we see here? If we go back here, right, we said here is an expression, okay, for the deflection, okay, across the beam. This is where did I get this? This is not, the problem is not as clear as oh, okay, yeah. All right, so I apologize. So this expression, okay, I gave you, and this is the expression for this configuration. Okay. Okay. This is expression for this configuration. Okay. So we can use it. All right. All right. And what we need though is to figure out so we just plug it in. Where is just make sure. This is what was in the slide, right?
Mm-hmm. You mean on Canvas?
Yeah, this is what I gave, right? This is what this is on the website, right? That's what I gave.
Yeah.
Okay. So just want to make sure this is embarrassing, but it happens. Yeah, that's the deflection across it. Okay, this deflection, yeah. Okay, sorry. This deflection Yeah. Yeah, okay. Now I know what I did. This deflection, this equation for deflection is this one right here. I should make this more clear. Okay. So this deflection right here is for that configuration, right? So if I know that configuration, what we need to do is a couple things. One, we need to apply it, okay, and calculate out, okay, what it is. So that's plugging it in right here, okay? So L is equal to L over 2, and also, yeah, this is very confusing. This is very confusing. So this is, you plug it in here, you plug in this is the minus, so this is going to be the deflection downward. This is the deflection upward, okay, using P over 2. Okay. Is this right? I have to make sure I do this. Yeah, this is right. Okay. And then this expression right here, okay, is for the deflection across this beam when there's a moment applied. Okay, so let's break this down. Because this is not as, this was all given, right? But it's not super clear from what I can tell. Okay. So let me just get my notes so I can see. I'll do two things at the same time. So once we know m naught, m0, m0, m naught is equal to -1/8 p over L, okay, we need to use superposition again to calculate deflection. Okay, and the expression that we're using, this expression right here, okay, is not super clear, but it's for I want to make sure I got this right. Yeah, I don't know if I did it, if I was clear in my video, but it should be for this one. Okay. So what we have is expression v of x is equal to px squared 3l minus x, okay, over 6 EI. Is that? Make sure that's right. Yeah. Okay, that's, yeah, okay, that's the expression, okay? So this is for and this is at a given location X. All right. So if we go back, all right, to what we have here, we have two situations where the deflection is due to P, and one where there's a deflection due to a moment. Okay, and this is a little bit tricky, and we did a little bit of the game. So let's write it out as a superposition. Okay, so what we're saying is and we're interested in deflection in the middle when there's a force P being applied this way. Okay. Yep. So we're going to say that this is equal to with P being applied there and deflection there, okay, plus it's going to be equal to deflection in the middle, okay, when a force of P over 2 is being applied at the end, plus we want to know the deflection in the middle when there's a moment, okay, and not being applied at the end. All right, do we agree on this? Okay, sorry it's taking me a little while to get through this. Okay, so let's break it down. Okay, let's look at what's happening over here. So the length of this region right there is L over 2, right? It's halfway. So if I want, and I was given this equation here, so if I want to calculate the delta, right, this delta 1 here, the rest is just along for the ride. Okay, so now if I look at delta 1, it's going to end up being negative, right, because I've defined delta 1 upward, but P is going downward. Okay, so what I can do is I can say that I've got a minus P, because it's a full load P, then I've got, where am I? I'm at a length L over 2, so I plug in X equals L over 2. Okay, this X is position, this L is length. So now, this length is only, because this is all along for the ride. Right, this is along for ride. Okay, so this is 3L over 2. This is at the end of that half beam, and this is over 6 EI. Okay, any questions on that? Are we good? This one has a length of L, right? So the beam length is L, but this is at L over 2. So X equals L over 2. So now, when we write out the expression for delta 2, and we use this equation, all right, what do we use? What do we use for our force? So you guys help me. What do I?
The moment in the middle created by P over 2?
No, because this is the deflection, right? So we're just looking at deflection. So you tell me. I want to rewrite this expression to reflect this situation, and this applies to this. So what is the force?
P over 2.
Right. So it's P over 2. Okay. Then what do I put in for X? Where am I?
The full length.
No, X is where I'm interested in, right? So I'm interested in X equals L over 2 because I'm halfway across, right? So then I plug in L over 2. Okay, what is my length? My length is just L, so I use this. So that's 3L. And then my X, what is it again? It's just L over 2. Okay, all over 6 EI. That was confusing, right? A little bit? It's the difference between X and the length.
I understand that.
You understand
Okay, just
that?
for everybody.
Huh?
I'm still just kind of confused as to why we can use the same equation
Yeah,
for
just X, it's
all
wherever
three
where
types
the
of
displacement
deflection.
is along
Right.
the X to the beam, you just
It's-
plug that.
It's because we are, that's a very good question, okay? We're able to use this one equation for these two situations because it's giving us deflection across the beam or along the beam as a function of X, right? And in this particular situation, this region is just along for the ride, this L over 2 length, it's just along for the ride. So then this just looks like this situation.
Oh, okay.
Okay, right? This is right. It's just you can essentially delete all of this, right? You just get rid of it.
And then it's just a situation on a shorter beam.
That's right. You've got it. So then I change my L here from L to L over 2.
Okay.
Does that make sense?
Yeah, I got it.
Okay. And then the third one.
Wait, question for the second one?
Yes.
I mean, other than just plugging in X, doesn't it kind of seem weird that we're multiplying the force by the distance from the displacement and not from the distance from the force? When you do the P2 L over 2 squared.
This you're talking about this section right here.
Yeah, like I understand like why you just plug in L over 2 for X, but like,
Why do I plug in P over 2 here?
no, I know why it's P over 2 because it's half the force, but
Yeah.
it's L over 2 even though it's a full distance away from the, like, let's say all the way on the left is like the point
Because
that
it's
way.
X there.
Yeah.
Okay, and where I'm interested in is that X equals L over 2.
Yeah.
Okay, and then it's a full length, which I just keep
Okay,
there.
alright, that's fine.
Yeah.
I don't know.
No, it's good. It's confusing, right?
Yeah.
Like
Well,
you
I
asked
get-
me about this question. I hadn't looked at it recently. I was like, wait a second. Okay, and then we're good. All right.
Like, I
But
understand why, like, I understand, like, you just plug the L over 2 in because it's where the displacement is along X, but.
yeah, well the X
Okay,
is
but it accounts for the full length of the beam in the second part.
correct.
Okay, I get that.
Okay, we're good? Good. And then the last one, okay, we actually need one more piece of information, right? Which is over here. We need to know what is the displacement across or along the beam, okay, as a function of X given an MO, okay, or M naught. All right, your mode of operation, okay? And in this case, all right, we're going to use, so the equation we want is v of x equals mo x squared over 2ei.
This is another equation, right? I guess?
Huh?
This is another equation, I guess.
Yeah, this is another, well, it's another equation that's been previously solved, right? So, I mean, the basic principle here is someone has done the hard work, or you have done the hard work previously, so you know what the expressions for displacement are across the beam under different configurations, or under that particular configuration. So now we want to use that on a more complicated problem. Okay, so maybe I should write it out. Maybe I should use a different color too. I don't know. Let's use green, right? The other expression we're using here is v of x is equal to m not L squared over 2ei, and that's for the situation like that.
That's if the displacement was, you're looking for the deflection at the end of the beam.
Oh yeah, if I
Yeah,
want it
yeah,
at,
yeah.
sorry,
That's
yeah,
okay,
yeah,
that's okay.
Yep.
Alright,
there we go. All right, and this is if we're along the beam.
anywhere.
Thank you, Matt.
That's okay.
All right, so now, in that case, right, this one's the most straightforward one probably, right, where I put in MO,
Which is 1/8 PL.
yeah, or minus, so in this case, right, it's, we calculated out that it's minus 1/8 PL, okay? And that makes sense, it's actually, so it's actually resisting, pushing back up, it's going the opposite direction, right? So MO, and then we're halfway across, right? So that's 1/2 L squared over 2EI, where MO is equal to minus 1/8 PL, okay? Because it's resisting, it's keeping it from
Going down,
going down.
like this way.
Okay, and so that's, I think that's pretty much it. So then the V of, or the displacement of L2, right, is going to be equal to delta 1 plus delta 2 plus delta 1.
Alright, this is it. So that's really good. Yeah, this is it. So it is.
Okay. Yes, Aaron.
25.4. What's the position of P?
Okay, hold on. Let's take a look. So
Is the answer supposed to be negative?
yeah, right? Because what's going on, right? Our convention is that this V, right, is positive when it's upward, and this beam is got a load going downward, so it's
this
going
would
to be
give us
negative.
the negative y value of how far it deflects at that point.
Yeah.
Okay.
So is P 381 or negative? Like if is P positive or negative? Like are all the negative signs
Oh,
in
right.
the
If-
equation
so-
accounting for that?
Well, if P, right, is given, or pretty much any value for a force is given, and the force is in that direction, right? Then you're going to use. You got to be very careful, but you're going to use, because you have a minus, right? We did minus 5P here, right? And we did minus here, right? So that you're going to put in a positive P for all these. Okay. Okay, there was a question about 25.4.
Yeah, so where's P located on the beam?
Okay, so
Does that or does not matter for some reason?
say that again, Aaron.
Where's P located on the beam?
It's halfway
So
across.
this doesn't say that.
Okay, that's halfway.
Okay, thank you.
Yes.
I think my foundation right. They didn't have to write it down.
Yeah. So this is
Yeah.
the distance L. this is a distance.
I have the little light amount. Yeah.
L over 2. Good.
What was the difference between, what was the difference between?
I honestly don't know. I don't know why. I did it a little bit differently, but what I had before should have been the same thing, it just wasn't.
Yeah, Mike, I think I don't know about your
Yeah, well, I mean, I didn't have n as a different value for whatever it was I had on the or whatever. Was equal to, so I don't want to just break like whatever it works out.
When we do these problems, if it's like say a cylinder instead of like a beam, would it change like the values for like M range that, or would that?
So in that case, where does the cross-sectional geometry come into play, and what variable?
I.
Yeah, that's it.
That's the one that would change, was like
Yep.
say a cylinder.
Yep. If it was a cylindrical cross-section, yes, or a circular cross-section.
Thank you.
What do you think the grade cutoffs are gonna look like?
I don't know. People, yeah, we'll see. I have been impressed with everyone's effort, so I'm hoping that no one really bombs and that no one has to get an F. Alright.
What does that mean about a D?
That's a low bar. Is that a low bar? Is that too low a bar?
Is this class what's this class a prerequisite
It's for like a few classes.
Mechanics and materials,
It's a few classes. I was gonna take some notes.
Isn't this class?
That's why
no, I'm sorry, that's design, design and mechanical components,
Yeah.
DMC.
You teach that too, right?
I have in the past, but I won't be teaching it in the fall.
I don't think I'm taking it.
When do I take it?
I'm gonna think like,
Right? When do people usually take that?
I'm gonna.
If it's a prerequisite, if this is a prerequisite for that first, yeah, next.
I'm still very confused. Why is mechatronics required for measurements of mechanical?
We've asked him this again many times. He doesn't know.
So
Yeah.
just send me a message. Send me a message.
Oh, we
This
asked
is-
why CAD was necessary for what? Is that what the question was? Yeah, yeah.
All right. You want to have? Can I talk to you for a sec? Sure. Yeah. This,
Not a fucking clue.
Hey.
Stuff's not up yet.
If I do good on this, I got it. You got it.
I just hope I do better than
What do you get on the first one? Or you got a
I got
guy?
an 18 and 17.
Oh, you're
18 on this.
18 and 17.
Oh, 18.
You didn't-
So if I get if I
You
get
got like
30,
85s.
Yeah.
You got like 85 solid.
But I'm worried that I'm gonna end up with 82 or something.
What do you have on
Maybe
homework?
you'll
What do you
find
have on homework? What do you have on homework?
like a 91.
Well, there's still
Oh,
participation here. So
see, I'm more sitting here. It's like I'm gonna have like, assuming I get like the average of what I have, right? Like I just get the same as what my overall average is right now. I'm gonna have like a 63, 64.
Wait, what answer
I
did you guys
swear
get?
to God.
That
What answer did you
should
get?
be a G.
What?
That was a micro.
So
I know, that's what I'm
wait,
saying. I
you're-
swear to God, if I get a fucking
I'll
B in
just
the class
tell you
from
what
that,
you're interested in.
somebody.
This is what I got.
Saying that very high strength.
Okay.
Just tell me, just
Be correct. Just-
Yeah. That, honestly, that's a good point.
I don't know. Last semester it started at 78, but I think people also did a lot worse last semester. So
Oh, because it was
And what
a
is it?
normal class, not people
Was
at
it
the
the R?
Like,
yeah, well, yeah, but that's what I'm saying. It's like 78 is a little too close for comfort, considering that people do a lot better in this class.
Honestly, I think I'm taking.
Wait. What's this? The whole answer?
that's my answer, yeah.
Because I got that for this. I mean, it's not gonna say.
Wait, that's 20, oh yeah, that's 4.5.
What where did you say that?
No, one of those questions he has a word wrong. It says 24 question 3 was actually 25.
Wait, what's it?
Oh, no, yeah, I have to just do that.
Do we got any who were doing this for session 24?
No, I was working something like that, trying to get the internals in, but I'm trying to.
Let me know if you guys just fucking get any of them.
Wait, for what? What question?
24. Yeah.
So why do I? My cousin's working something. Oh my god. Oh my god.
That's so sick. I'm not. But how long they have it? They're trying to cover some of their plants. Like, oh yeah, we're really, we like growing plants. Great, it's friendly.
Yeah, because no one in my family, but my oldest cousin does, and so does her boyfriend's family. That's they all live there.
It's a triangle.
So I just like very different vibes.
Oh, I agree.
I like this thing.
Yes.
Everyone.
Aaron, you park at the shop? You should. I
Oh,
think park at the
yeah,
shop and then walk all the way there.
We all go to South Carolina.
Oh,
Yeah, I'm just
Parking
like
lot
on the
across
beach.
the street.
Is this the thing?
My friends, like, we're not exchange.
Welcome.
He doesn't do that at all.
How's your 4th of July, Professor?
Yeah.
Mom.
It was honestly great.
That's
It was,
Yeah.
I mean,
parents.
how to put it, it was sad in one respect. I took my family to the airport early in the morning, so that I was by myself.
Oh, where's your family?
But then I was able to hang out with some friends, and we went to the shore.
Oh, yes.
And I was able to do a little surfing, a little boogie boarding, and then I tried something new. I've never used one of these things before. That's called like a hand plane. So it's like a boogie board that you strap to your hand. It's like this little thing. And
bodyboarding.
yeah, it's like body surfing.
What's it called?
It's like hand planing. I'm not sure. There's probably
What's it? You know, like body surfing, where you just like swim and catch the wave.
Yeah.
Like, with your hands out.
Yeah.
Oh, yeah.
You just
So
you
it's like a
you
little-
attach like this little
Oh,
boogie
it's a
board.
small board.
Yeah.
Yeah.
Imagine like a flipper, like a single flipper, but for like your hand, you just like, attach it, and it's like easier to like. glide on the water.
yeah. Okay.
So
I
you
used
put your
this
hands
when
down.
I used to swim. We used to use these.
Wait, no. You wouldn't use it when you're swimming.
Yeah. Is this it? Is this little thing? Is that not it?
I think it's kind of.
It's kind of like
A
that.
little bit.
Is that not it?
You're not.
How big is it? How big is it?
It's big and it's
Oh.
floaty, so
Oh,
you
I
think
cannot
you
you
swim
you
with
wouldn't
that.
you wouldn't
Yeah.
swim with
If
it.
it was smaller and not floaty, then I would use it. when I was-
Yes, that I agree.
Okay.
So it's not for it's really remarkable. I had never used one before, and it took me like I wasn't 100% successful, but once you kind of put your hand out there, and you're trying to get it so like it's kind of planing, and you swim with your other arm. At least that's what I did, and I kick like crazy, and then you catch it, and you're like, whoa! Like this thing is suddenly like supporting you, and you go a whole lot farther than you do if you're just
like body surfing.
body surfing.
Yeah,
It's
yeah.
like body surfing, but with this. It was like really
That's
weird. Like I was like, and you can control it, like you just tilt
Yeah,
it
that's
back and
cool.
forth. It was fun. I'm sure it's like this little piece, right? We know something about materials, right? It's this little piece of foam. I don't know. I don't want to say. I have an idea how much they charge for this little piece of foam, right? That has a strap on it, or actually some companies make them that they don't have a strap on them, but it, they can charge a nice little penny for something that adds a lot of fun. So you went to the shore as well, Matt? You went to the shore as well?
Yesterday?
Yeah.
No, yesterday. So I was expecting to study in the morning and then spend the rest of my day like grilling with my friends.
Yes.
But all my friends left. So I was by myself. So I bought like hot dogs and stuff, and I just literally grilled by myself. Like I literally, I put the grill in by myself. I sit in the chair, like I have a beer, whatever. And that was my day.
Okay.
Yeah.
So and then I had dinner with a friend. I just picked up some Wawa sandwiches, and
Wawa is the best one, yes.
yeah, I picked up. No endorsement here, but just picked up some certain sandwiches from a particular place that's very popular in New Jersey, and we had a nice little dinner. And I was so exhausted. I was like, I'm gonna do some work, and I got I went to bed I was in bed by 9:30.
Put you in a food coma.
Try the smoothies there. They have really good
I've been
smoothies.
spending way too much
I'm telling
time
you,
in
they might have really good smoothies.
I've been
I
spending
have
way
like
too much
an
money
80
somewhere
for
in
a
Wawa.
class. If I get a similar grade on a final, is that gonna be an A or?
Maybe just
We can talk about it out there if you want. I don't know if we want to I mean,
Well, we're just speculating. You've heard they might be good. We don't know that.
What's that?
We can't confirm it or not. We just said they might be good. They might be.
everything is awesome. Everything is cool when you're part of the team. Everything is awesome.
I think A should start at 70.
You know what? I should have shot the fire with fire earlier. Like,
You know what, Mike, I support that.
My aunt's neighbor nearly lit their deck on fire.
Oh.
dude, what are you talking about?
Oh, they were like,
we just went from grades to my aunt. That's pretty awesome. All right.
Talking about?
They were lighting on
Like
fireworks,
setting
and we're at the
off
end of the dock smoking cigars, and we look over and we're like, that firework fuse has been going for a while, and my cousin was like, that's just a fire. And there was no one standing there, and we had to go over and knock on their door and be like, hey, is that supposed to be happening? And they were like, no. And
So then you took a bucket of water over there or something?
they went out and they
Put the fire out.
brought a bucket, they were just dipping it into the bay and putting it out.
Um,
They managed to put it out, yeah.
that would be a very sad way to lose your peer.
Oh, yeah.
Hell of a firework.
I'd love to have a peer. I don't have a peer, but sounds awesome to have a peer. So,
It's like fireworks from the two as well.
huh?
It was like fireworks from the two that are
Oh, you know how that ends.
I really want, I have a comment, I really want to strap a firework like a Roman candle to the end of my arrow, shoot it, just see how far it goes.
You ever
There
have a Roman
was,
candle fight?
I saw a video the other day, I thought it was hilarious. There's two people, it looked something straight out of Harry Potter. If they take sticks and they strapped a thing of fireworks at the end of each, and they lit them, and then they stood 40 yards apart, and they just had they were firing at each other, and it literally looked exactly like a Harry Potter fight, just green and red,
Wow.
plus a cluster of red, just a red light is streaming across.
If they could just get a Patronus, right?
Yeah.
Wow.
I've
Well,
always wanted to do that.
yeah. I mean,
I definitely should.
I guess for the sake of safety, because we talked about safety factors here, right? We talked about, well, yeah, for the sake of, I did read an article, or I didn't read it, I saw the headline. There was this article in the news, in a reputable source, just questioning why we continue to have all these activities when there are thousands of people who end up in the emergency room.
Is that really?
Every
4th of July?
That's what. Let's take a look. Let's take a look. So we're gonna go to it was
I bet you
an
it was
AP
always-
News article.
Because 4th of July was on a Tuesday, which is the worst possible day.
Honestly, yes, it's probably not on the trend.
Yeah,
Because Wednesday, people might give you Thursday and Friday. Monday, they're gonna give you the Monday.
I want to be the one that they roll candles and light it.
You ever had a Roman candle fight? It's so
Yeah,
cool.
I've had it but dude, I got
You gotta do it in the day, so it's hard to see.
Oh, I did at night.
Yeah.
I had a spark land on my back actually from that. That's not the whole thing, but I had a little spark on my back.
There's this guy that, some guy cut him off, when he was biking, so he put a bunch of fireworks in front of his bike, and just shot him while he was biking.
okay. So the headline was.
Yeah.
The headline was thousands of emergency room trips haven't stopped Independence Day traditions yet. Here's why.
And they never will.
Well, here's
Like
yes.
letting the sky fly. I love America.
The 4th of July is Americana at its core, typically resulting in more than 10,000 trips to the emergency room. The pyrotechnics.
We just love blowing stuff up in the sky.
Just for fireworks?
Huh? What they say in their reporting, those pyrotechnics also make it an especially dangerous holiday, typically resulting in more than 10,000 trips to the emergency room. Yet fireworks remain at the center of Independence Day, a holiday 247 years in the making.
Does anyone have like a silver Sharpie?
Dude, you asked.
Dude,
Yeah.
well, I
I
don't.
need it so bad.
A silver
Or
Sharpie.
just like anything that will show up on black.
White.
Right. Yeah, white would also work, I suppose.
Pencil, good one, pencils.
You have paper on your notebook. Why don't you just write on the paper?
Because it doesn't stay, and I also hate this little thing flapping around.
Oh, you're trying to put your name on it?
Well, I'm trying to put something on, because I hate this little thing flapping around, and if I take it off, then I don't know which way up whenever I take out the notebook, and it's a pain in the butt.
How about when the spiral's on the left?
Yeah, how would that like?
Oh, yeah, really upside down. No, I just did it in my head. I just did it in my head.
yeah.
I'm so sorry.
You know, you could just bite it.
I was gonna say
Bite a
fold
corner.
the corners.
Oh yeah, you could.
It looks so clean, though.
That's true.
Just laser and
Calculate how much stress you have to induce to result in plastic deformation
Do you know
in the
mechanical-
corner of your notebook.
Do you know mechanical engineering measurements is a difficult class? Because it doesn't seem that difficult, but everyone says it is, but I don't, how can it be that difficult? You're measuring stuff.
You're measuring small things.
Well, there, you know, experimentalists. So I'm an experimentalist, right? Experimentalists have a lot of work cut out for them, right? Because you have to figure out, okay, what is it that you're measuring? Is it relevant? Are you telling the truth? You know, what's the correlation? And how does it relate to how does it relate to underlying physics?
Yeah.
Yeah. So we've got a few minutes left. Are there any burning questions?
Yeah, do we gotta take the final?
No one is. It's an interesting question that you ask because parents are faced with this, right? Like a child says, "You can't make me do this," and they're like, "Well, how do you answer that?" That's a hard question to answer.
Are we talking about teachers? Doesn't say it to teachers?
Or just parents, like, have you ever told your mom or dad or your guardian, like, "You can't make me do this"?
Well, yeah, I think a pretty good response for that is normally like,
I think I have
okay,
that
well,
question.
then then you can't get this.
Take your phone away.
So there are consequences that you can say, well, there are consequences to our actions. Yes.
But I don't want them. I want to not take the final and have zero consequences.
If we came into
That is, so that, yeah, so that is,
I think consequences.
that
are
is
bad.
a life,
Like,
that's kind of like almost an eternal principle, right? Like, life has, our actions lead to consequences, right?
What if our final was whoever makes the biggest popsicle tower or something? I think that would be pretty.
Hold on.
I think he's onto something.
I say we should do the marshmallow and toothpick.
I think I'd have a fair
That would be a
fight.
little bit better.
In my intro to engineering class in 8th grade, there was a project where we had to make
That's it.
like a roller coaster.
Mm-hmm.
Yes.
Yeah. And one of the things on the rubric was like design. and he specifically said like you can't have tape like everywhere or whatever, like because that would make it look ugly. But you also needed a theme for your roller coaster. And the day before it was due, we dropped it and smashed it apart. And so we just taped it all back together, and then we were like, oh, we're gonna get 0 for that. So we made the theme tape. So we got like some marks taken off for it being a stupid theme, but he couldn't take any marks off for the design because it matched the theme.
Yes.
And he was like, you got me here.
So, I hope that many of you do have very successful careers that are in engineering and use some of what we have talked about. Nonetheless, I would be stupid. Well, maybe I shouldn't say that. That's not a nice word. I'd be a little bit ignorant to think that some of you will go off and do wonderful things that have very little to do with what we're discussing, right? And one likely path also is that you start off in a technical position as an engineer and you become a manager. And so I think this idea of being able to think outside the box, Michael, is very useful. It's very useful. Okay. You look at a lot of what happens in terms of innovation in our country. A lot of it is not based on using mathematical formulas, okay, to solve problems that have been solved by others previously. A lot of it is trying things out and seeing what works and sticks, and then trying to explain it afterward.
Yes. Throwing that out.
What was that, Tyler?
When worst comes to worst, we could be submarine engineers because apparently the qualifications
Whoa! Whoa!
They did have training. They did have
No.
training.
Okay, so whoa. So, I have a very, very, very high respect for those who do try new things, like we're talking about, right? And even with what you've seen in the innovation in the space, the commercialization of space, shall we say, they did build on what, there have been collaborations between government and private companies for years to try not to repeat some of the same mistakes, right? But yes, people will say space is dangerous, right? It's still a very high risk operation, but I think we've seen recently that the possibility of getting people and machines to space, it's gotten better, right? I think submarines and deep water exploration probably has an opportunity to go through some of the same lessons that we've seen in the space race and beyond.
All the blatant red flags that they walked past and decided, you know what, those are.
Well, did you see that engineer that they fired because he said that it wasn't seaworthy? And they just fired him instead of listening to him. And then they sued him for breaking his NDA because he came out and said this is going to kill people.
He was the safety inspector. The reason they fired him was because he refused to let it
Because
pass.
he did his job.
It was only supposed to be used for like a very small fraction of the depth that it was trying to go to.
So it's like, I think the window on it was rated for less than 1/3 of the depth that they were trying to get.
That's what it was. The one window is only supposed to take less than a third of the pressure.
So, and we've also seen, NASA has, had some interesting things happen, and if you look at what happened with Challenger and the O-rings and Feynman, and kind of that historic case, the culture plays a role in safety as well, right? So keep thinking outside the box, but tomorrow you probably want to think inside the box a little bit, but be creative. Like with superposition, right? We've talked about it's kind of a creative little exercise, right? You gotta this plus this plus this, or this minus this plus this, right? There's a little bit of creativity in there.
Did you ever see that NASA rocket in the 70s back when they were programming with punch cards? They forgot to take the average derivative of something. They were just taking, they forgot the little dot that made it average instead of just normal. and this was for the guidance computer. And so it kept trying to correct for deviations that were on the order of like a couple of millimeters that I could have just ignored. It kept trying to correct to that, but it would overcorrect because it's not, the actual fins couldn't aim it that accurately.
Yeah.
So it just started going like this, and then it plummeted to the ground. And on the punch cards, it was 3 punch holes that they missed, that if they had remembered to punch them, they would have saved like $70 million.
Oh, okay, yeah. I'm not familiar with that one. I am familiar with the metric mix-up.
Oh,
Right.
that's what got
The Mars, that we lost the Mars lander on that because of the Imperial and the metric units.
So maybe we can't just switch entirely to metric anymore.
Huh?
So let's switch kind of switch now.
Well, I mean, I think so RFR, you don't,
No metric.
yeah, no metric,
I
right?
mean, sometimes.
Some will,
Some, yeah. This is the thing.
Everything.
We have a lot of tooling, right, that has already been
Yeah.
made for Imperial units. So
a lot of it's like, I don't know, I think we made everything metric, because if you look at like a lot of that tool, like the tools that we use that have like measurements or like are based off of Imperial, they also have a setting for metric. Any ruler, yardstick, anything we look at also has markers on the other side,
But
right?
you do like with machinery, I think the units don't match up.
yeah, you can't. Yeah,
do
that like the
Whereas
tooling.
I was like with actually like doing like milling and everything, you kind of like it says
It's a
the
little
same
bit
thing.
different for
Just
that.
spinning that fast, it's like
Even
Just
our
think
machine,
something-
the like metric for almost did this metric.
Okay. Oh wow, we've gone beyond. Well, that concludes our final session before the final. We'll see you tomorrow. Good luck.
How many questions is this?
Probably 3, right?
16.
Fewer than in the previous finals because we have less time.